Next question, number 3. Rank the following compounds in decreasing order of basicity and explain your answer. So here we have a total of 3 compounds, compound 1, compound 2 and compound 3. Now if we look at the 3 compounds, the most important thing for us to do in order to identify the basicity or the basic strength, we have to look at the presence of the groups in the compound. So we will focus on compound 2 first. In compound 2, we have the benzene ring over here. Benzene ring attached to NH2 groups. Now the benzene ring is an electron withdrawing group. Now what does this electron withdrawing group do? It actually attracts the electrons, or rather we can say it is actually going to attract the lone pair of electrons from the nitrogen atom towards it will pull the electron towards the benzene ring. So when it does that, the partial negative charge on the nitrogen atom will be decreased. So this will cause difficulty, or this will cause the lone pairs to be not available in order to form bonds with the hydrogen ion when they are trying to accept the proton. Therefore, since they are less able to use the lone pairs, this will have, or compound 2 will have the lowest basic strength. Now with that, let us move on to the other 2 compounds. Now looking at compound 1 and compound 3, both of them actually have alkyl groups. So alkyl groups are electron donating groups. That is for compound 1. Now if we look at compound 3, the same thing happens here. We have the alkyl group. Also electron donating group. Now with that, the most important thing to notice here is that for compound 3, we have yet another alkyl group, which is of course still the electron donating groups. Now this would mean that compound 1's basic strength will be much lower than compound 3 simply because of the presence of one electron donating group, whereby the presence of this group will actually cause the electron density or the partial negative charge on the nitrogen to become increased, whereby the lone pair is more available for the accepting of protons so that they can form the bonding and they can exhibit the basic properties. Now as for compound 3, it will have the highest basic strength because it will have 2 alkyl groups, or rather 2 electron donating groups that will further increase the partial negative charge on the nitrogen atom and of course make it more easier to accept the protons. Alright, so here we have the answers to question number 3. So remember, for the order you have to start from the highest, the compound having the highest basic strength, and then moving down to the weaker basic strength. After that, what you see here is only one half of the answer. So here the answer starts from compound 2 onwards, explaining on what happens in compound 2, the electron withdrawing groups and so on. So EWG here refers to electron withdrawing groups. I have used the I have abbreviated it because there's no space to write out the complete, the full name, but you may actually write down as electron withdrawing group. In bracket you can use EWG. Alright, so this would refer to lone pair electrons from the nitrogen atom. Okay, and I think everything else is here. Alright, this is the second half of the answer on compound 1 and compound 3. So similarly here, EDG refers to electron donating group, but please write them in full first before using the abbreviation. So this would be electrons, okay, presence of 2 electron donating groups, and yeah, so this is the whole part of the answer.